Okay, so we are going to start talking about graphs. So chapter 4 is on functions and relations, and functions are just, what does anyone know what a function is? What do you think, Brennan?
A function is like what you put into.
Yeah. There's like an input and an output, right? And yeah, exactly. So you put something in and you get something out, right? And a graph is a visual representation of a function. When you put in some data, you get out some data. So it's relating between two different pieces of data. And for example, in graph A right here, what are the two pieces of data? Actually, in graph A, B, and C, what are the two pieces of data that we're talking about here? Montreal? Time and temperature, exactly. So we've got time down here on the what axis? X-axis. And on the y-axis, we've got temperature. So there's some relationship between time and temperature. Can anybody think of what these graphs might be collecting the data of? Don't just say time and temperature. Montreal, what do you think?
The temperature at a certain time of the day.
Okay, so like during the day, what the temperature might be, right? Good, that's a good idea. Okay, so up here, there's a word problem, sort of, just a paragraph description, and that paragraph is describing what's happening in one of the graphs. And you have to match the graph to that paragraph. So can I get somebody to read this out loud? Go ahead.
The air temperature was constant for several hours at the beginning of the day, and then rose steadily for several hours. It stayed the same temperature for most of the day before dropping sharply at sundown. Choose the graph that best represents the situation.
Okay, so a lot of things happened throughout the day. What are the things, when you go to approach a word problem, I see a lot of you guys underlining and circling. What are you doing when you're underlining and circling in a word problem? What are you looking for there? The key points, right? What are some of the key points in this word problem? The air temperature was constant. So constant, what does constant mean? Stayed the same, right? So the air temperature stayed the same for several hours at the beginning of the day. So right now, just from that information, I can tell it's either going to be which graph? A or B. It can't be C, because what happened in C? C went immediately up. So it can't be C, because that's rising from the very beginning. So I already know it's not that graph. Okay, what's my next keyword? Rose steadily. So then it rose steadily for several hours. All right, so we've got to choose between A and B. Can I tell right now which one it's going to be? No, why not? What happens in A and B? They both rise steadily, right, Matthew? Then what happens next? Then the temperature stayed the same, which is why you said that it's got to be B, right? Yeah, because in A, it rose, but then what happened? It started dropping. Whereas in B, it went up and then it stayed the same. So once it stays the same, then you know it's got to be graph B. So when you're matching a graph to a situation, how do you think you should approach these types of problems? How do you think you should approach these types of problems? What did we just do there? Look at keywords, okay. Montreal? Take those pictures and follow them along to those keywords. Good. Do you want to immediately try to say, like, which is the right answer, or do you want to try to eliminate the wrong ones as you go? Eliminate the wrong ones as you go, because then you're immediately down to fewer choices, so the likelihood that you'll get it right increases by a lot if you start eliminating the wrong answers. Okay, these are the same graphs, but a different situation. So this situation says the air temperature increased steadily for several hours and then remained constant. At the end of the day, the temperature increased slightly again before dropping sharply. Choose the graph above that best, or graph below, I guess, that best depicts this situation. So which graph do you think this would have to be? C. This would have to be C. Why? You know right away that it increased steadily for several hours, so it has to be C, because as we talked about with A and B, what happened with A and B in the beginning of the day? They stayed constant at the beginning of the day. Good. All right. Which one do you think is most like the weather in Houston?
C.
Why do you think that?
Because it's always changing.
Okay, it changes a lot, right? And what happens usually in the morning?
It's cold.
It's cooler in the morning, and then it does what? Spikes pretty quickly once the sun goes up, right? So it gets hot, and then around midday, it usually stays here. Do you think it goes up at the end of the day? Maybe not. All right, so this might be more likely, it might make more sense if it was like this graph just without the beginning part. Okay, so we've got two different types of graphs. We've got a continuous graph, and we've got a discrete graph. Just looking at the pictures, can someone tell me what the difference is between a continuous graph on the left and the discrete graph on the right? What's the difference there? What do you think? Angel? They have different. Yeah, one has dots and one is a line, right? What does it mean when there's dots like this in a discrete graph? What does it mean if it's got dots? What do you think? Montreal, what do you think? It's kind of like a scatter plot? Okay, what does that mean? A scatter plot was a good first step. Brendan?
Another difference is that one of them is linear and one of them is not.
Oh, okay. All right, which one's not linear?
Graph B,
Why?
because it doesn't have a straight line.
Okay, graph B is not a straight line, whereas this might be a little bit more linear. Okay. When do you use a scatter plot? When do you use a scatter plot? When your data might be all over the place, Matthew? Graphing points, okay. So each of these points represents one very specific answer, right? There's 1 year that goes with the number of people. This is the graph of theme park attendance. What's happening with the theme park attendance over the year? It's declining. So fewer people are going to the theme park, right? But the reason that it's not a continuous graph is because there's one specific number for each year. So let's say this was like 1995, and that was like a really big year for theme parks, all right? So there was a very specific number of people who went to theme parks in 1995. This next dot would then represent what? 96. What would the next dot represent? 97, 98, 99. So it's a discrete graph because you could say, like in 1995, there were 65,000 people that went to this theme park. In the next year, there were 64,320. Each of those dots represents one specific piece of data, whereas this graph right here represents a linear relationship or a nonlinear relationship in this case. It's linear right here and not right here. But it represents something that's constantly evolving throughout the day. There's not one specific data point that you're looking at. You're just looking for a general trend over the course of the day. All right? So a continuous graph is represented by just a line. A discrete graph is formed by distinct points. So let's go back to this one actually for a second. All right. What if I asked you to write a situation for this graph B? If I asked you to write a situation for this graph B, could anybody tell me the situation for this? So again, could anybody give me like a word problem for that graph B? Tell me about that time and that temperature. What's happening at first? Okay, so we start with a constant temperature, right? Then what happens? Braylon? Yeah, it goes up. Okay, then what happens next? Stays constant for a little while, and then what happens? It drops sharply, right? It declines immediately. What about this one right here? What would be a situation that you could tell me about this graph right there? Braylon? Yeah, the number of people at a theme park slowly declined over the course of some number of years, right? So over the course of a few years, the number of people going to a theme park slowly declined. All right, so if I give you this situation here, which says Simon is selling candles to raise money for a school dance. For each candle he sells, the school will get $2.50. He has 10 candles that he can sell. So is this going to be a continuous graph, so measuring trends, or does this measure distinct data points? What do you think? Braylon, what do you think? It measures data points, right? Because if he sells one candle, how much money does he make? $2.50. If he sells 2 candles, how much data does he make? Or how much data? How much money does he make? $5. 3 candles? $7.50. Okay, so you can plot that. Would it look like a wavy line, or would it look like points on like a scatter plot? Yeah, it would look like dots like a scatter plot. So my first dot is at 0, 0, because that's if he sells none, right? You guys told me if he sells 1, how much does he make? So then I put a dot right here, like halfway between 1 and like here and 5. What about 2? 5. 3? Okay. 4? 10? Okay, 10. All right. And then it's going to keep going like that. Is it going to move at all, or is it going to stay on a constant rate? Stay at a constant rate. Because does the price of the candles ever change? No, the price of the candles stays the same. Therefore, it's going to increase at a constant rate. So my graph would look something like that. All right, I think I put too many data points, but you get the idea. All right, so is this continuous or discrete? This is discrete. All right, because there is a data point for each number. What about this? Angelique's heart rate is being monitored while she exercises on a treadmill. While walking, her heart rate remains the same. As she increases her pace, her heart rate rises at a steady rate. When she begins to run, her heart rate increases more rapidly and then remains high while she runs. As she decreases her pace, her heart rate slows down and returns to her normal rate. So can I get somebody to come up here and try to put this on the graph? Angel? So remember, we want to look at those keywords first. So let's help Angel out. What's the first thing that's happening with Angelique's heart rate? It's steady, right? It's staying the same. So that means it's going to start where? Like, what's it going to look like, Angel? What's her heart rate? If her heart rate remains the same, so when she first starts, she's walking, her heart rate remains the same, what would that look like on the graph? A straight line. Where do you think it would go? Where should this graph start? You're going to do a horizontal line, right? Go ahead and put your horizontal line on the graph. All right. Can you start it all the way at the beginning of time? Good. Okay, quick question. Why didn't Angel do that starting at the very bottom? Usually we start graphs at 0, 0. Why didn't Angel start his graph at 0, 0? The person has a heartbeat. Angelique is alive, right? It can't be at 0 because then Angelique would be dead and she could not be walking, right? All right, so she started and it stayed at a constant rate. What happened next? So she increases her pace, so her heart rate rises. Okay, and then what happens? Then she starts to run, and so her heart rate goes really fast up. That looks, do you want to adjust anything about that? I might adjust that part of it, if I were you. I might, so that's rising pretty quickly. It's supposed to rise like slowly. So if her heart rate rises slowly, okay, and then starts rising really quickly. Good, okay. There you go. All right, and then what happened? So then she decreases her pace, so her heart rate slows and returns to her normal rate. Oh, wait, did she die? All right, perfect. That looks great. All right. I'm going to make this just a little more obvious just so we make sure we know this. But so it rose slowly. That's a little not obvious enough. And then it spiked. And then she kept living afterwards. So I'm going to keep Angelique alive. All right. So right here, she was just walking. Here, she was like maybe jogging, right? What was she doing here? Running. What was she doing here?
Some jogging.
Starting to slow down, maybe back to a jog. And then she was doing what here? Probably walking or just resting. She sat down on the couch. She was very tired. All right, but not dead, so she's still got a heart rate. So make sure when you're doing this, if you look at these problems, you don't start it down here. Just keep in mind it's supposed to tell an actual real-life situation. We don't want Angelique to be dead, okay? Especially if she's going to start running next. Yeah, I saw you. Poor Angelique. All right. Okay. What situation could we write for this graph? What's a possible situation for this graph?
Something grows really fast.
All right, something. What are we talking about here? We're talking about water, and we're talking about time. All right, so over the course of some time, some stuff happened to the water, right? So let's say, for instance, let's do the red part. What happened in the red part? So the water level rose. Did it rise quickly, slowly? It rose pretty quickly, right? So it rose quickly. All right, what happened in my blue section? It stayed the same, so the stayed level. All right, and then what happened in my green section? All right, so in my green level, the water level, quickly, slowly? Pretty quickly. All right, so what could be a situation that this graph might depict? It could be a bathtub. Why? Yeah, you sit in it, right? So it could be a bath. You fill your tub up. You hang out in it. I don't, because I think baths are weird. All right. If you take baths, that's fine. All right. I think they're a little. I don't like sitting in my own dirt. All right. My kid takes a bath, obviously, but all right. And then what happens to the water? You empty the tub, right? Can anyone think of another situation this might depict? What else could this be, Brendan? Justify that, and I'll accept it. So someone drowning, well, how? Oh no, don't make it a baby. Don't make it a baby.
He's playing around. His dad is fishing. He's playing around the shore. He drops in. He's like, yeah. His dad jumps in. The water, the sea level rises up a little bit, but that's a little bit right there.
Oh, okay.
And then they get out like that because he saves them. That's so weird.
This is like a lake?
Yes, no, see,
How is the
he
water
drowned really
changing
fast.
that much?
He drowned really fast, and then he like,
That if you got okay, I think you're missing the part where the water level has to increase, not like the baby.
Doesn't the water level increase if something gets into the ocean?
Be a minuscule amount. Like if
So
you,
increasing.
why is this baby laying in the ocean?
No, that's like
Where is this baby's father?
fishing.
Fishing? So when the baby gets into the ocean, the water level rises.
yes.
The baby rises with
The
it.
baby weighs a lot. so
People
why not?
float. All right, I don't accept that situation. All right, can anybody give me another one? I don't take that one. Montreal.
All right, so it was a pond, and it was a thunderstorm.
Okay.
And the water level went up, and then it stayed there for like 6 hours.
Uh-huh.
Then the sun sucked it up.
Yeah, that's perfect. Okay, so there was a thunderstorm. So this is a pond, and there was a thunderstorm. And as the thunderstorm happened, the water level went up, and then it stayed the same for a while, and then it got sunny out, and so the sun sucked it up, which we call evaporation, right? So then evaporation happened, and the pond level went back down. That's perfect. Can anyone think of one more example of what this could be? I mean, one more example of what this graph could be.
Can I redeem myself?
If another baby's dying, no. Yes, you can redeem yourself. All right.
Okay, so like a person drops an ice cube into their Coke.
Okay.
It rises, but then they get the ice cube out, and then it goes back down.
Yeah, okay, that's perfect. So they're pouring the Coke maybe, right? So at first they pour the Coke and they put an ice cube in and the water level rises. And then either they fish out the ice cube or maybe they drink some, right? Maybe they drink some of the Coke and then the level will go down. Perfect. Redemption done. All right, and nobody died. Okay, any questions on how to find a graph, how to match a graph, how to create a situation for a graph?